Yes. How can you still not understand this? Now, number three, I didn't actually give you an example of this. I wanted to see what you guys would come up with. -1 is the lowest. X, what's the highest? Infinity. So you could have written this. Could you have said equal? No. Could you ever get to infinity? No. So you can't say equal. But. This is cumbersome, isn't it? There's a lot of symbols there that we don't need. If x goes all the way up to infinity, doesn't that just mean that x is greater than or equal to -1? And please notice that is way less work. They mean the same thing. If -1 is lower than x, but x goes all the way up to infinity, then x is simply greater than or equal to -1. Is everybody cool with that? I didn't show you this in your notes because I wanted to see if anybody would make this connection. Everybody good? All right. And then the range is -3, y, 1, 2, 3, 4, 5. Any questions on 1, 2, and 3? Going once. Going twice. Amni. Pardon me? One, two, three, four, five. It is 6. I'm getting old. I need some bifocals. What? Oh yeah, it's 3. I need me some bifocals. What? Everybody good? 1, 2, 3, 4, 5, 6?
What?
Okay.
I don't know if I know it. Wow.
Why? 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 Because there's no line. Why? Six domain elements, 5 range elements. Why? 2 Y's. Function or not a function? Function. Why?
Because it's not going that way that they overlap.
They don't overlap vertically. No, because Chihuahuas suck. Only on the range. Why? 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 Yeah, that's why the little pink circle is over range. Why? Because there is range here and there. Why not?
Because it starts before the next one.
What? 1, 2, 3. Because I need bifocals. We've been over this. It's 4. Why here is there no U? They overlap right there. But it ends at 6. Function or not? No, because that vertical line does hit 2. Levi. Okay, so Levi just asked a very good question that most of you are going to ignore, but I'm going to answer it anyway. So you're asking that, yes? Okay, so this line goes up to and almost hits positive 2, but this one does. So it starts up right away at 2. So this gets the positive 1.99999999999, and then it starts again right at 2. So it's still continuous. Only if that's not included. But it was included. No.
So then, is there a third cumulative after this?
Will be. Now, ladies and gentlemen, because of those 2 arrows, it's negative infinity to positive infinity. Math guys don't like that, so they write this. X is all the real numbers. You don't need to know all the fancy ways of writing this, but some of your tests, some of the software I use to make your tests does write this properly. I am more concerned with you understanding the concept behind it than the minutiae of how to write it down perfectly. I'll let somebody else worry about that. I want you leaving here knowing how to do it. Real numbers. So every single number, from negative infinity up to positive infinity, all the fractions, all the decimals, everything. And then range is Negative 3, 0, 3, 4.
Yes. Please.
Is everybody good? All right. Now, how did we do with 183? You had the answers. Oh,
Oh, wait, what?
we didn't do 183 yet. Right. Okay. 5-2, page 185. Okay, listen please. Listen please. The stuff on the left is all stuff you should be able to get from the graph. Okay? We're going to do stuff with this graph that is new. So don't do anything stupid like draw a bunch of, stick men jumping off of cliffs and things in the white space over here, because I need that white space. You answer these 1, 2, 3, 4, 5, 6 questions. Okay. What is the IV? Jesse. Why? Absolutely. There's people on that boat that aren't diving. So the DV becomes the depth. Lovely. How many minutes did the dive last? 30. Lovely. Nobody said 29. That makes me so happy. At what times did the diver stop her descent? 4 to 8 minutes. And 10 to 14 minutes. Now, here we're going to talk about something a little bit new here. How did you know this? A flat line. Why? Depth stopped changing. Come on in.
Can I get the keys to your car?
Of course you can. I left it unlocked, I thought.
Yeah, I know, but we set this started.
Oh, you got to run it, of course, because you poured
Power steering.
steering fluid into the new reservoir. Hey, good catch on that, Emily. I know you do. That's why I keep bringing my car back. Flat line because depth stopped changing. What never stops? Time. Greatest depth? 20 meters. How long at that depth? Domain and range. Depth stopped changing while time went on. Ladies and gentlemen, really? You just did a whole page on this. What is the lowest domain value? 0. Does it exist? Yes, at one point she was not diving. What goes here? No. We have data here. Say it. Time, which is less than or equal to 30. What's the range? Depth. 20. All right, now we learn new stuff. Please pay attention. The first thing we are going to learn doesn't need anything written down. I'm going to say it and you are going to listen to me. Is a graph a drawing of what is happening in the real world, or is it a representation of data? It is a representation of data. Because in the real world, when she dives off the boat, where does she go? Down. Did the graph go down? No. Graphs represent data. They are not what is happening in the real world. Okay? Good. Next thing we need to talk about is we need to talk about what this stuff means. Now, please notice that for the first section of this graph, which I'm going to draw in this weird, I don't even know what color that's supposed to be. It is light orange, apparently. Now, for that, back in the day, that was flesh. Back in the day in Crayola boxes, that was flesh. I look around the room, I don't see a lot of us with that color. No, it was called flesh on old Crayola packages. Because, of course, there's a lot of white people in America. Now, anyways, back to business. What is happening in reality for that section of the graph? Describe to me in words, what is she doing? She is swimming downwards over a period of time, yes? Now, if you are covering a distance in a period of time, what do you have? I'll give you an example. When I drive my car, I drive kilometers per hour, a distance divided by a time. So I'll ask again. If I have a distance, meters, divided by a time, in a certain amount of time, what do I have? You're going to say velocity, but you're going to say speed, but the real answer is you have a ratio that makes a rate. Because it doesn't have to be distance and time. What it really is I is dv divided by iv gets us a rate. Everybody understand? Now, what is this? And I'm supposed to be using light orange, idiot. What is that distance? 12. What is that distance? 4. So what I have there is a rate of 12 meters per 4 minutes. Now, does that make sense as a rate? Would I say I drove my car down the street at 200 kilometers per 4 hours? No, that's idiotic, isn't it? What number do we like in the denominator if we are going to give a rate? 1. So what number should be there? 1. So I divide it by 4. So I divide that by 4. What was the rate of her descent? 3 meters per minute. Everybody cool? Now, in red, what happened there? She went deeper. Did she go deeper faster or slower? How do you know it is faster? Because it is steeper. She went further distance in less time. What was her rate there? What is that? 8 over what? 2. 8 over 2 becomes 4 meters per minute. Agreed? Okay. What was her ascent speed? How fast did she come back up to the surface? Do you think anything changes? No. What is this distance? 20 over what is this distance? 16. 20 over 16 doesn't work as nicely as 12 and 4 and 8 and 2. But what did I do? 8 and 2, what math did I do? Division, got 4. 12 and 4, what math did I do? Division, so what do I do here? 20 divided by 16, what is it? Out come the calculators. 1.25 meters per minute. So, what does this tell us? The steeper the line, the more don't say speed. The more change is occurring because it might not be speed, right? Let me give you an example. The bell rings, right? You all race out of here because, you do. Pretend it's not last block. You got to go to your next class, yes? Some of you will have a class down in the gym. Some of the other people in your class will have been in art with Miss Griffin. Who will get to the gym first? The people from Miss Griffin's class or you from here? Miss Griffin's class, right? A few of them will arrive almost right when the bell rings, yes? So if I was graphing time and kids in the room, right after the bell, there wouldn't be a lot of kids arriving over time, would there? 3 or 4 minutes after the bell, what happens? A lot of kids arrive. Then the bell rings, and then because it's Abbey Senior, a few more kids arrive. And then they get packed and they don't have to do anything about it. Right? This is when the change was happening the most. The most dependent variable change in the least independent variable change. Everybody cool? All right. Let us move along then, cabbages. Now we are going to reverse the order. Now you have no information, but you have a graph. Write me a story. Is this English class? Do I insist that your story has character development? Do I insist that your story has conflict, person versus self, and person versus the environment? Do I insist that your story has rising action? Do I insist that your story has a climax? Do I insist that your story has denouement? No. You need 3 sentences here. 1 for that, 1 for that, and 1 for that. I am going to write the real life thing that happened here. Go. All right. Okay, are we done? 3 sentences. Everybody ready? Yes. This is what happened. Because I'm a good big brother. That's what you do. You got to keep them in line. Am I right, big brothers? How many of you are little siblings? So this would have been done to you. Don't even talk to me about middle children. Surprise, surprise. I'm kidding. Look at me. Then there isn't a middle child. There's 2. That doesn't count. All right, now, ladies and gentlemen, I use this question to discuss grading in this unit. All right? On a scale of 1 to 4, 1, filled can, dumped can. So that's what happened, right? Gets you 1 out of 4. Agreed? 2 out of 4. Filled the can, walked over, dumped can. Right? 3 out of 4. Took a partially full can, filled it, walked over to the garden, dumped it. 3. 4 out of 4. Took a partially filled can, filled it at a rate of 0.75 liters in 30 seconds. That's no good. We don't measure rates that way. What is it really? 1.5 liters per minute. Filled it. Walked for... Yes. Walked. Not every phone. 1, 2, 3, 4. Walked for 40 seconds and dumped it. Dumped it at a rate of 1.75 in 20 seconds, which makes no sense. What do I have to do to 1.75 to have it make sense? Multiply by 3, which is 5.25 liters per minute. That gets you 4 out of 4. Does everybody see the levels? Does everybody see why those levels exist? If you get to here, you understand this properly. As a matter of fact, if you actually did this, you would get 4 out of 4, which is exceeding my expectations. Aight? Aight. Turn the page over. Listen to me and listen to me carefully. A great many of you refuse to take your notes in pencil. do this graph in pencil because 90% of you are gonna screw it up. Go. Attempt to draw me this graph with this info on this axis. How many lines will I need? How many things happen? 4. So I'm going to need 4 different sections of the graph. Go. All right. Everybody should at least have been able to do that. Wait, I would have done this in hours. Sorry. Everybody should have gotten there. First section of the graph, we're going to draw in this dark pink. First year of the trip, Jack leaves home, travels 140 kilometers at a constant speed. 1, 2, 1 hour, and let's go up by 20s. It doesn't matter what we really go up by. Everybody agree? Doesn't matter what you go up by, it's cool. Everybody agree? Actually, I'm going to make that a little smaller. We will go up by 50s. All right, everybody cool? Now, 0, 0. 2 hours in, I'm at 140. Since it was a constant speed, what line is this? What kind of line? Straight. Now, is that realistic? No, of course not, because when he started driving, there'd be stop signs and crap. But we're cool, yeah? How fast did he drive? 70 kilometers an hour. Nice. Now, next section in this weird blue color. Light blue. He visits grandma for 1 hour. So what? Straight across till 3. Why? Because he stayed there for 1 hour. Distance didn't change. Light green. What happened now? Drives back home. So where does the line go? 50 kilometers, then he stops. So I'm at 140, so I got to go back to where? No, I'm only driving 50K. So I got to stop at 90. Does it tell me how fast I was driving? So we make an assumption he's maintaining the same speed, yes? So we're going to keep that same slope down to 90 and then stop for 30. Agreed? How many of you have this right now? Hands up, be proud. How many of you have that?
Like because we were copying it?
No, because you drew it yourself. Because if you were just copying me, you did it wrong. And if you drew it yourself, you did it wrong. And we're about to discuss why. What should it have been? This is no good. It should have been up and flat. This is wrong. This is right. And now we are going to learn why. Have I moved right now? No, I'm standing still, yes? Is time going on? So have I covered any distance? All right, excellent. Everybody ready? Okay, here we go. What did I just do? How many steps? 3 steps. So I've moved a distance of 3 steps over a period of time, yes? Okay. Which is? How many steps? So how many steps did I take? So how much distance did I cover? 6 steps. But where am I? Back where I started. So did I go anywhere? But I did go somewhere. You saw me go over there and come back. Did I go somewhere? Excellent. So this brings us to a physics discussion that some of you will already know because you have done science and some of you may not. There are 2 measurements available to us here. One is distance, and one is displacement. Distance is what we call distance is scalar, which means it only has a magnitude, which is a size. How far did I move? 6 steps. I moved 6 steps. All right? Your car measures on its odometer the distance your car travels. Yes? If I drive my car from my house to here, that's 32 kilometers. And here back home, that's 32 kilometers. That's 64 kilometers. My car says on the little dial, if you've got an old car with a dial, or on the little digital thing, if you've got a newer car with a digital thing, that I drove 64 kilometers. Even though I ended up back where I started. Everybody understand? That is a distance. Displacement is a vector, which means it has a magnitude and a direction. Now, you're intelligent young people. How many different directions can I move the tip of this pen? So many. How many? Infinitely, yes? In reality, there is an infinite amount of directions available to me for the tip of this pen, yes? In math, how many directions are there? 2. What are they? No. No. Pardon, Sebastian? Positive and negative. Math has 2 directions. Positive and negative. In the real world, we must use 2 directions to describe movement. This is how we do it. Positive movement is said to be away from where you started. All right? It is also to the right. It is also up. It is also north. It is also, what else could it be? Right, up, north. Clockwise, another good one. Forwards, that's another good one. All right? Now, what then is negative? The return. Left, down, south, back, east, west, because east is positive. Everybody understand? So, again, to give you a visual, from my perspective and your perspective, my rights and lefts and your rights and lefts are different, right? Because you're looking at me, we're mirrors of each other. So left and right isn't a good way to do this. I am moving away from my starting point, yes? So, how far have I displaced myself when I stop moving? You beat the round again! You're like a master criminal! All right. So, I am how far? Ladies and gentlemen, what is my distance traveled right now? 4. What is my displacement? No. Positive 4. Now, wait. No, it's not. And you'll see why. Just don't give me away. Everybody cool? Now. What is my distance traveled? 8. What is my displacement? 0. Positive 4. Negative 4. Wait for it. Wait for it. Why is it positive 1 in my description of this situation? I've stepped away. Now, if we go back to left and right, which would be better, wouldn't it? Go back to left and right. I'm moving left for me, yes? Positive 1, 2, 3, 4. Negative 1, 2, 3, 4, back to 0. And then negative 1 because I'm going left. So my displacement from my perspective is what? Negative 1 step. What is my displacement from your perspective? Positive 1. Again, that's bad because you're looking at me, I'm looking at you, it screws things up. What would be a better way to do it? I could turn around and show you my butt. Nobody wants to see that. What's another way I could do it? You. I could show you my butt, but nobody wants to see that. I want to see your butts. So, what else would work? What's the same no matter where you're looking? North, east, southwest. That's north, right? Is north positive or negative? Positive. So I move 4 steps north, which is positive, 4 steps south, which is negative, and I move 1 more step south, so I'm at negative 1 because I moved 1 step south. Does everyone understand? Now, because this graph is distance, it is not allowed to go downwards, is it? Because distance keeps rising. So, I return home taking 2 more hours. Now, I took longer to get home, didn't I? Because I already did part of the drive. So, can it be this same slope? What must it be? Steeper or shallower? Shallower. Now, stop for a second. This is distance. This is displacement. Now, all of you heard distance and displacement and have stopped listening now. If I change this title to distance from home, is that a distance or displacement graph? Displacement. So even though it says distance, because I've added the qualifier that I'm going home, obviously I have to have this happen. Does everyone understand? Excellent. Let's look at the next one. The next one, if you have not been paying attention, you're going to screw it up. Don't write it down. Just think about it for a minute. Describe it in your head. All right, everybody's got it in their head? You don't have to write it down. I want everybody thinking about it. Has everybody got an idea to describe this? All right, here is what is actually happening. Thank you. It's a race. So at the beginning of the race, time 0, is she moving? No. So what happens from O origin to A? She speeds up to what speed? 8 meters per second. Right? Right? No, it's not. Speed is this. 8 meters per second. I'm about to explain why. Now, when we had distance and time, we were able to find a velocity, yes? Because it's distance divided by time, kilometers divided by hours. In this case, I have speed in a time, which means this right here is still a change, isn't it? Gentlemen, shut up. I'll start polite by saying gentlemen, and I'll finish with what I want to happen. Shut up. Is this still changing my dependent variable? Okay. So what is happening now is my speed is changing over time, which is what Austin said, I believe. That is acceleration. Right? So what she is doing is she is accelerating at 4 meters per second squared, because it's 4 meters per second. 2 seconds, s times s squared. That's a physics question. We're not going to go any further with that. But that is what is happening there. What happens from A to B? Right, she maintains top speed of 8 meters per second. What happens from B to C? What happens at B? Yeah, what happened in a race? Right. At B, she crosses the finish line and she slows down. Now, why isn't it that? She doesn't run into a wall, right? That would make the Olympics awesome if it was a brick wall at the end. See who would really have the guts to run into it full speed. I'm just kidding. You don't have to do that, Usain Bolt. We're happy with the finish line. Who cares? Usain Bolt at 70 will run faster than every one of us in this room. He could. Oh, yes, he will. Okay. All right. Yeah, because a teenager in North America is ready to run against him. I understand he's fast. He's not Usain Bolt fast. Oh, he's slow. Okay. All right. Everybody cool? Now listen. I'm going to give you a hint. This is a gift to you if you take physics. This is acceleration. Some of you will call this deceleration. Don't. Physics teachers go 8. This is negative acceleration. It's a different thing. Right? I'm caring about the math. Mr. Morrison will take care of the difference. Your job tonight, your homework is do some work from 183 and 184 and attempt to draw the graphs on page 187. There are 4 of them. P183, 184, and 187.